What is the meaning of that? Oxidation of C means alcohol. We studied alcohol on oxidation gives carboxylic acid, right?
Yes, ma'am.
So it is clear that is alcohol. When you write the alcohol, but the product is given, dehydration but-1-ene. But-1-ene is the product, means 4 carbons are there in the alcohol. Like that, with reason you have to give the answer. Understood?
Yes,
Simply you cannot write this is alcohol, this is acid alcohol. Actually, the question is with equation.
oh,
If you don't know, leave space, we will do it later. How to write the answer.
physical.
You have to write the answer. Okay. Now, physical properties. I asked you, so many compounds we studied till now, right?
Boiling point, melting point. This and that.
All boiling point, melting point only, but we studied haloalkane, haloarine, aldehyde, ketone, alcohol, ether. So out of all those compounds, which one has highest boiling point?
Phenol.
Alcohol.
Alcohol. Yes.
Alcohol.
Alcohol. But now when we study this carboxylic acid, the highest boiling point is for carboxylic acid compared to alcohol also. That is the important point you have to remember here. Okay. Compared to carboxylic acid, alcohol also, this one is having highest boiling point. What will be the reason for the boiling point, high boiling point?
OH bond.
Ma'am, high molecular mass.
High molecular mass. Then
Oh.
another important point in boiling point.
Ma'am, less branching.
See the structure RCOH. Oh, double bond.
Eh,
OH is there now.
you said no. OH bond.
Extensive hydrogen bonding is there. This oxygen can also involve in hydrogen bonding. OH. So there is extensive hydrogen bonding and higher molecular mass. Okay, these are the 2 points of why it is having highest boiling point. Okay, right. So carboxylic acids are
Ma'am, what's the heading?
physical properties. You wrote the heading, right? Okay, Rehan, write physical properties. Under that you write carboxylic acids are higher boiling liquids than aldehydes ketones, aldehydes, ketones, and even alcohols. Of comparable molecular masses.
Ma'am.
pre-board we have all the 10 lessons.
Eh?
For pre-board we have all the 10 lessons.
Yeah.
Biomolecules also.
Biomolecule, but I will tell you till which portion the questions are coming, only the first part. But don't tell anyone.
It's not the full chapter.
Okay, ma'am.
Not from the full chapter, only the first small topic.
Thank you, ma'am.
Okay.
Don't tell anyone, but.
Yes, ma'am. We didn't hear anything.
Okay, right. Even alcohols of comparable molecular masses. This is due to more extensive association of molecules, more extensive association of molecules through intermolecular hydrogen bonding. Through intermolecular hydrogen bonding. But then you draw the hydrogen bonding or only two. And we studied that acetic acid exists as a dimer. Even in the vapor state also, it's difficult to break the hydrogen bonding. RCOOH.
No. Okay.
Here hydrogen bond between these two molecules. So extensive hydrogen bonding is there. That is the reason why this carboxylic acids they have that, because it can come as like multiple choice question. They will give you 4 compounds. Which one is having highest boiling point? Okay, completed.
One second. Yes, ma'am. Complete. Done, ma'am.
Okay. Now, chemical properties. Chemical properties. Okay, chemical property, under that first you write reactions involving
chemical properties or chemical reactions?
both are same, chemical property or chemical reaction. Under chemical property we study chemical reactions. Reactions involving cleavage cleavage of, in carboxylic acid, different bonds are there. R, C double bond O is there, then OH bond is there. Okay, so we classify the reactions according to
reactions involving cleavage of
reactions involving first we are studying reactions involving cleavage of this one, oxygen hydrogen bond cleavage.
Okay.
OH bond. Same thing we studied in alcohol. Do you remember?
Yes.
ROH bond. OH bond undergo cleavage. What was the most important point we studied there? OH bond undergo cleavage. Anyone remember? OH, H will go, then in place of that something will come. H is easily removed.
Active metals.
What was the point?
Williamson ether synthesis. Williams.
That is an ether preparation.
Okay.
Here, removal of hydrogen. We studied it under the heading what?
Acidic nature.
Acidic nature. Do you remember? Hydrogen is removed as H plus. To support that, we studied some equations, some reactions. Reaction with the metal, reaction with the sodium hydroxide, reaction with the sodium hydrogen carbonate. To prove that alcohols are acidic in nature. So same thing here. So we are studying reactions involving cleavage of this oxygen hydrogen bond. So under that you write acidity of carboxylic acids. Acidity of carboxylic acids. So remember, alcohols are acidic, right? But when you compare alcohol and carboxylic acid, which one is most acidic? When you compare mineral acid like sulfuric acid, nitric acid, hydrochloric acid, they are the strongest acid. Then compared to mineral acid, carboxylic acids are weaker acid. But compared to alcohols, carboxylic acids are strong. So the acidity of carboxylic acids are the strongest acid. Amongst all the organic compounds, they are the most acidic. Okay, write one point. Carboxylic acids are weaker than mineral acids. Those who don't know, you write bracket sulfuric acid, hydrochloric acid, and weaker than mineral acids, but stronger than ADEEB is here. ADEEB Sheikh.
Yes, ma'am.
Very good. But stronger than alcohols, and phenols. Now we will give That same equation we studied in alcohol as evidence for acidic nature of carboxylic acid. And we wrote this one as a test for no. I think we wrote this question, right? How will you distinguish between benzoic acid and phenol? We wrote it.
Yes, ma'am.
Wrote it, right? Afif. That question is based on this point or in phenol. എഴുതിയിട്ടുണ്ടോ? If it is not there, we will write. Okay, acidity, first one you write. They react with the active metals and even with the mild bases or very weak bases. Okay, do you remember in phenol we studied phenol will react with the sodium, that metal, or sodium hydroxide, strong base. That is how we distinguish. But carboxylic acid, they're highly acidic. So they can even react with a very weak base like sodium hydrogen carbonate. So this is a test to distinguish between phenol and any acid, benzoic acid. That's what I asked. We wrote it or not. Okay, even with a weak acid, a weak base, it can react. So you write one. That is a test to distinguish between phenol and benzoic acid. Because benzoic acid, stronger acid than phenol. So benzoic acid will react even with a mild base like sodium hydrogen carbonate. Do you know sodium hydrogen carbonate react with acid? 10th standard you studied, right? What is the product? Any acid. You studied mineral acid in 10th standard, HCl plus sodium hydrogen carbonate. What was the main product?
Salt and water.
Only salt and water. Most important product. Carbon dioxide.
Oh, yes.
Do you remember? So from here you will get carbon dioxide, then salt and water. So this evolution of carbon dioxide easily you can test using lime water. Okay. That is why it is used as a test to distinguish between phenol and benzoic acid. Phenol will not answer the test because phenol is not that acidic compared to benzoic acid. So here instead of mineral acid, if you write benzoic acid, that will produce carbon dioxide. So that is a test to distinguish between phenol and anyway you write one reaction with active metal. Any acid you write CS3COOH, acetic acid, reacts with the sodium metal. This hydrogen will be replaced with the sodium. Means you will get sodium salt of acetic acid. Means this hydrogen is it can be easily removed as H plus. In place of that H plus, Na will come.
So, ma'am, you said that brisk effervescence but phenol does not that one. Okay.
No, that is another question. How will you distinguish? This is first you write this one.
Okay.
That I'll give you as question and answer. So sodium metal, this one will react. You wrote this reaction. This OH bond will break. That type of reaction we are studying now. Then in place of hydrogen, Na will come. Okay. Boys, you wrote. Next one reaction with the sodium hydroxide also you write. Strong base. Naturally, it will react with a strong base, right? Even with the weak base, that is the point. Water will be eliminated. Again, you will get oxygen, hydrogen bond will break. You will get CS3COONA plus water. So that hydrogen can be replaced. Now, next one. These two reactions we studied for phenol or aliphatic alcohol also. But this one we did not study for alcohol because that is a mild base. CS3COOH plus NaHCO3, sodium hydrogen carbonate. Then carbon dioxide is one product. CS3COONA COONA plus carbon dioxide, salt, carbon dioxide plus water. Okay, now you write. How will you distinguish between how will you distinguish between phenol and benzoic acid? What is the answer?
Yeah.
Right? Benzoic acid on reaction with the this one, sodium hydrogen carbonate, NaHCO3, produces what? What is your observation?
Brisk
effervescence.
brisk
Brisk effervescence.
but phenol will not does not.
Ma'am, NaHCO3 is baking soda, right?
Yeah.
NaHCO3, sodium hydrogen carbonate or sodium bicarbonate. Benzoic acid on reaction with the NaHCO3, which is a mild base.
Why is it called bicarbonate if there's only one carbonate ion?
HCO3 is there. That group is called bicarbonate.
Okay.
CO3 is carbonate. CO3 2 minus is carbonate. This is HCO3 minus, bicarbonate. Or another name, hydrogen carbonate. So benzoic acid on reaction with the NaHCO3 produces brisk effervescence. Brisk effervescence due to the evolution of carbon dioxide. Then you write phenol does not react with the NaHCO3. Phenol does not react with NaHCO3. Okay, understood? So you can write the equation also. First you write benzoic acid. On reaction with NaHCO3. Okay, what is the product, ADEEB?
That one, sodium.
What will happen here?
Yeah, H will go, sodium will come, then it will produce H2O and CO2. COONA plus
H will
H2O.
go in place of H. Na will come.
Yeah, plus carbon dioxide plus H2O.
Plus water. So this carbon dioxide will appear as brisk effervescence. So you can test for carbon dioxide. Or you can see brisk effervescence. Then phenol, no reaction. Okay. Now, next heading. This is very important. Like, which one is more acidic, which one is least acidic, that type of question. Then you write effect of substituents on effect of substituents on acidity of carboxylic acid.
Heading.
Next subheading. Effect of substituents on acidity of carboxylic acids. Adi, what are you doing?
Ma'am, me?
Cooking.
Yes.
Mute your mic. Effect of substituents on acidity of carboxylic acids. Now listen. Those who studied that alcohol lesson, this is same thing. Very easy. That one. Do you remember we studied the acidity of alcohol and phenol? How will you say which one is more acidic, which one is less acidic? Based on?
Phenol is more acidic.
Based on?
Based on sp2 sp2 hybridization.
Based on what? How easily it can give H plus ion. That depends on what? Then only it will give H plus ion.
Resonance.
Depends on the stability of the ion. For the profit. Right.
Yes.
Phenol we studied. Phenoxide ion should be stable. Right. After elimination of hydrogen as H plus, leaving its electron here, you will get phenoxide ion. If this ion is stable, then very fast it will give H plus. So here also, acid, any acid is 3COOH. This is very strong acid means after removal of hydrogen as H plus. Hydrogen as H plus means leaving its electron here, hydrogen is going. Then negative charge will come here, like this, CS3, COO, negative charge. So any factor that should increase the charge or decrease the charge, then it will become more acidic. What we studied, if more charge or less charge is required for more acidity?
Less.
Less charge, isn't it? More
Yes.
charge accumulates on a single atom, it
Will
will
be unstable.
be unstable.
Yeah.
So less charge should be there on this oxygen. Means any factor which can take away this electron density from oxygen means electron
But if
withdrawing.
for that we have done also
Eh?
resonance.
Any resonance is there, but it's not that significant in acid.
Okay.
Phenol and phenol, it is more significant. So here, any electron withdrawing group is there on the carboxylic acid. Then negative charge on this carboxylate ion. This ion is carboxylate ion. There we studied in alcohol which ion? Which ion after removal of hydrogen as H plus? Name of the ion?
Ma'am, that one.
Alkoxide.
Alkoxide ion.
Yes.
If it is phenol, phenoxide ion. Isn't it? Phenoxide ion or alkoxide for aliphatic. Here it is carboxylate ion. If less charge is on this carboxylate ion, that will be more stable. So if any electron withdrawing group is there, that acid is more stable or that ion is more stable, then that will be a very strong acid because it can release hydrogen very fast. Because after removal of H plus, that ion is very stable. If the ion is not stable, it will not give hydrogen as H plus. That is the point you remember.
Okay.
All of you understood? Then I told you, you also like that. If you are comfortable, then only you will give something to others, right? First you make yourself comfortable. Same like that, this carboxylic acid also, if any factor which can make it stable after removing hydrogen as H plus, then only that will give H plus very fast. If any factor which make this ion unstable, then that will not give, that is weak acid. So electron withdrawing group, can you give an example for electron
NO2.
withdrawing group?
NO2.
NO2, then halogens, fluorine, chlorine, bromine, iodine. If any of that groups are there, that acid will be very strong because they withdraw the electron from the carboxylate, that group. And any electron releasing group, electron donating group, EDG, electron donating group.
It will destabilize the acid.
Yeah.
That will increase the negative charge on carboxylate ion. So the ion will be unstable. Okay. Then that will become weak acid. Is it clear?
Yes, ma'am.
And sometimes they give you this pK value. That also in alcohol I said. This is having small pK value. This is having this value. Which one is more stronger acid? Like that type of question.
If less, it is stronger. If more, it is weaker.
Smaller the pK value, stronger will be the acid. We wrote that point in alcohol also. Because I saw one question. This is having pK value 10 raised to 3. This is having 10. Which one is stronger acid? That type of question. So you write this point first. You write a note, NOT. Smaller the pK value, stronger will be the acid. Stronger will be the acid. Then you write.
Ma'am, why do we consider pKa instead of pH?
pK means that gives you the dissociation constant of the acid. Ka.
Okay. Okay,
pH and pH.
ma'am, because pH also measures the acidity of.
pH also you can say.
Okay.
But in your textbook, this table is given. Which one is having higher pK, lower pK?
Okay, ma'am. Okay.
Table is this.
Because we have to take it for base also. So
Base,
pKa
yeah.
is.
So here Ka value, because it is acid, no? Dissociation constant of the acid. So pK is same as pH only. Last year you studied. pKa is negative logarithm of Ka. The equilibrium reactions we studied. Okay. Oh, well. Next heading. You wrote the heading, effect of substituents on acidity of carboxylic acid. Then you write, below the note you write first point, electron withdrawing groups, EWG. Electron withdrawing groups. Electron withdrawing groups increases the acidity of carboxylic acids. Increases.
Ma'am, can you repeat before increases?
Eh?
Can you repeat again?
Electron withdrawing group, it increases the
EWG. Electron withdrawing groups increases the acidity of carboxylic acid by stabilizing the carboxylate ion. Okay, fast. By stabilizing the carboxylate ion. You know carboxylate ion, right? This is carboxylate ion, COO minus. Carboxylate ion through inductive effect. Electron withdrawing group, which inductive effect?
Plus I effect.
Plus ion.
minus
Withdrawing. So
Plus I means electron releasing.
releasing, pumping,
Negative electron.
pumping. Yes, sir.
For electron withdrawing group, bracket through inductive effect, bracket minus I effect. Minus inductive effect. Minus I effect and resonance effect. Minus I effect and resonance effect. Okay. Then you write some examples. Shanhil. Shahneil. Who is this Shahneil?
What ma'am? Shaqni.
Who is that?
Ma'am, basketball player.
From your class?
No ma'am. From America ma'am. Some other person.
Who is that? Shahneil.
Let him study.
Okay, listen. Then you write the different group comes. Which one will be most acidic? CF3. You write this order. CF3. Then another electron withdrawing group, NO2 group. Then cyano group. Then fluorine. Then chlorine, bromine. It is given in your book, right? It is there. pH phenyl. C6H5.
Ma'am, what about COH and CHO and that? Because COH also is electron withdrawing than CHO.
COH we are studying now about carboxylic acid.
Okay.
That is electron withdrawing. Meta-directing group. CLA, Br, then iodine.
Then phenol.
Then phenyl. pH means C6H5 group, phenyl. Okay. Then next one, electron donating groups, EDG. Electron donating groups. Destabilizes the carboxylate ion. Destabilizes the carboxylate ion through plus psi effect. Through plus psi effect.
Destabilizes ion.
Or decreases the stability of the carboxylate ion through plus psi effect. I thought now we can finish till carboxylate. Okay, fast.
Decreases stability of the
Carboxylate ion. Everything is based on the stability of carboxylate ion.
Ma'am, please can we do the next class ma'am?
By electron releasing. Electron pointing towards CO minus. More charge means less stable. Okay. Now write a question. Write fast. You have to study HVZ reaction. Which of the following acid is strongest and weakest? Which of the following acid is strongest and weakest? Which of the following acid is strongest and weakest? Okay, write fast. CCl3, CCl3COH, CHCl2COH, then CH2ClCOH. Okay, which one is the strongest? Because 3 electron withdrawing groups are there.
Yes.
Weakest, only one.
Then CH.
So you write the answer. Strongest, you write this one. CCl3COH. Weakest,
you.
CH2ClCOH. Weakest. Okay, next one. C6H5COH, CS3COH, CS3CH2COH. Adeep, which one is strongest?
Strongest is the second one. CH3COH.
First one.
Second one, CH3, electron releasing.
It will increase the density, right, Adi? What is this?
Oh, yeah. Sorry.
Because C6H5 we studied in electron withdrawing group, right?
Yeah.
These two are electron releasing groups. CS3 is electron releasing, this is also electron releasing.
Yes.
So compared to these 3 alkyl groups, this is electron withdrawing.
Yes,
so
ma'am.
Strongest this one, right? Strongest. Then methyl and ethyl, which one is more plus effect? Ethyl.
Ethyl.
So this is weakest. So strongest C6H5COH, weakest CS3CH.
Ma'am, the order will be CH3COH, then CH3CH2.
Sorry.
No, nothing. Plus.
Now next one. Now next week also one class. It is not over.
What, ma'am?
If your topics are not over, by next week we will conduct one more class.
Okay, 3-hour class.
Okay, out of these two, which one is strong, which one is weak?
This strong.
Ma'am, first one is strong.
Then
Ma'am,
second one,
because
it has
strong inductive effect. Ma'am, because in the second one, after 3 carbon atoms, the effect
there
of
is
inductive
no
effect. No inductive effect.
See here, this is hydrogen. Hydrogen means it is not electron releasing, not electron withdrawing. But here we have chlorine, but that is after 1, 2, 3. It is very far away from COH group. So that effect will disappear after 3rd carbon. Last year you studied, right? Minus I effect, plus I effect. After 3rd carbon, there is no inductive effect. So write the answer stronger. This HCOH. Weaker. This one. You write the answer. Reason here. Cl is away from COH group. Cl is away from COH group and there is no electron withdrawing effect or there is no minus I effect. Away from COH, so after third carbon there is no minus I effect. Mifsal.
Body.
What if that chlorine is in third carbon? Like in the second carbon?
Here,
That is far
Yeah.
only.
this carbon,
No.
then there is electron withdrawing effect.
Okay.
Minus I effect is there.
Okay.
Okay.
Um,
Here no effect. Then here minus I effect means this will be more acidic.
so then comparing with HCOH, then
HCOH, no group, no electron withdrawing, no electron releasing.
okay.
But if Cl is here,
Huh?
that is next to COH group, right?
Yes.
Then it is electron withdrawing.
Okay. In that case, the second one is the.
This will be more acidic.
Okay.
In that case.
He said only ClCOH. So like that.
Here, then it will become CS3, right?
How ClCOH?
CS3 is not directly attached to the carboxylate. Next one.
Okay.
Time കഴിഞ്ഞു. Only 2 minutes. Write fast. COOH, NO2. Out of these two, which one is more acidic?
NO2 is NO2 is electron.
This is most acidic.
More acidic. Yeah.
More acidic.
Yes.
But you should remember OCS3, electron releasing.
Yeah. Yes. Okay. Thank you.
So you write, this is, you know the reason, right? Presence of electron withdrawing group on aromatic ring.
Yes. Thank you.
Increases the acid strength, but electron releasing group decreases. Okay. Now also we have 3 pages left. Okay, thank you. So do that question I told you to do after the class. ABC.
Okay, ma'am. Thank you, ma'am. Thank you. Bye.
Thank you, ma'am.
Thank you, children.
Thank you, man.
Bye.
Thank you, ma'am.